Let's get started. Thank you. This is a really boring talk, so I thought I would wear a squirrel t-shirt to keep you all interested for the duration of the talk. That's not true. This is a very exciting talk because I have not one, not two, but 3 live demos for you today. I know what you're thinking. You're thinking, that's crazy. How could he possibly do 3 live demos? Well, let's see what happens. Everyone, please stay off the internet. It's my internet for the next half an hour. So, Decker. There was a OpenStack summit recently, and there was a thought leader conversation online, during which an OpenStack thought leader described Decker as a small project from some SI. So I thought this was quite interesting. Thank you for the publicity to that person. But let's break this down. Let's have a look at this. So who is some SI? Well, I'm very proud to tell you. I'm Colin Humphreys. I'm the CEO of CloudCredo. I want to say thank you very much to all of our clients and ecosystem members that have mentioned us today. We're working with a lot of people in the ecosystem, and it's been fantastic to hear about their success stories that we've helped them with. So what about CloudCredo, and what have I been working on? So I'm very happy to tell you I delivered the first ever production Cloud Foundry, which was about 2 years ago, running some applications for an insurance company in London. And that's still running to this day, and it's had no downtime, which is amazing, because it was Cloud Foundry v1, and some of the components were a little interesting. Very proud to say, I believe, please anyone contradict me on this, I've run the largest production Cloud Foundry, which was approximately 600 virtual machines spread across 4 clouds. There's a blog post I wrote on this. It's on cloudfoundry.org. This was a system for a UK charity. This took approximately 700,000 transactions over the course of 6 hours. And as you can see, $105 million on the project. So that was a tremendous success with Cloud Foundry. I'm also on the Cloud Foundry advisory board, and we've joined the foundation at the silver level. So really excited about that. So that gives you some background on some SI. Let's have a little look at the small project. So why have we built Decker? Well, my purpose motive, the thing that I want to do that gets me out of bed in the morning, is fast feedback. I want to enable fast feedback of business ideas. I think if we can test out ideas and find out very quickly if they're good ideas or bad ideas, we can learn quickly. And the faster we learn, the more successful we will be. And as a business, if you want to be successful and beat your competitors, you need to be able to learn faster than they do. And this is what I'm trying to enable. And this is the key idea of books like Lean Startup and 4 Steps to the Epiphany. So, if we have an idea, as you can see here at the bottom left, apologies, my slides are being slightly cut here. We've got an idea, we need to learn. So how do we get to the learn box at the top right? Well, traditionally, we go through all these hoops. And this is a value chain for people delivering an application. So if we have an idea, we need to do some infrastructure stuff. We buy our data center, we buy some metal. Then we do some platform level stuff, configure the OS, app server, DB server. We write some software, deploy the software, and then we learn. So I was unfortunate enough to work on a project a few years ago where we had a fantastic Gantt chart that mapped out this process from idea to learning in a 15-minute granularity over the course of 3 years. So some poor business person, they'd had an idea saying, we actually wanted to bring, it was a website to test out selling an insurance product, and they wanted to test out whether or not this was a good idea to sell this insurance product. And the fantastic project managers and technical architects came back with this Gantt chart and said, OK, we'll do that for you, no problem at all, we'll do all these things. We bought some land for a data center and those kind of things. And it was going to be a 3-year feedback cycle. What can you learn if it takes you 3 years to find out if your business idea is a good idea? Well, not a lot is the answer to that. So if you look at this, and you think about this, and you look at the things we were doing, it actually quite closely resembles the cloud stack, because we've got some infrastructure stuff, some platform stuff, some software stuff. So again, apologies, but you can see this is the standard, the cloud stack. So we've got software as a service, platform as a service, infrastructure as a service. And quite often, businesses will go to AWS, fire up some infrastructure. They'll then use that infrastructure to provide a platform. They'll then deploy their applications to that platform, and then end up with some software that users can consume. And this can take a long time. So I want to change this. I want to say, if you're going to build something, if you're going to build a service and make it come to life, what you should do is break that service down into small components, and you should deliver them at a high level as possible in the stack. So if software exists that can meet your users' needs, then use it. So something like mapping being an example. Use Google Maps. Don't reinvent your mapping service. So I'm going to be, I believe, the only person at this summit to say, do not use Cloud Foundry. If software as a service exists to meet your needs, it's going to be faster than writing an app and putting it into Cloud Foundry. So if you can avoid doing that and get faster feedback using software as a service, then use software as a service. If you need to innovate and you need to create something new, then OK. Create an app, push it into platform as a service. This will then run the app. This creates software as a service, and your users can then consume that. But don't go down to infrastructure. Don't go down to AWS. Don't go down to data center and those kind of things, because you're wasting your time. You're delaying your feedback. So if you're going to deploy your applications to platform as a service, as we know, we're here at the CF Summit, you're going to use Cloud Foundry. So I'm going to be the only person here doing a very straightforward demo of CF, just to illustrate the concepts. If you haven't used CF, what are you doing here? But let's give this a quick go. So I'm connected to a Cloud Foundry here. You can see I've got a space called Decker in the system domain. You can see the domain there is an elastic IP from Amazon. So in this directory, I have a very straightforward Ruby application. If I cat that, you can see this is a fantastic Ruby application doing some CloudCredo marketing. So if I CF push CF test, it's going to take my application. It's going to think about connecting to AWS. It's going to ask me some questions first, accept the defaults. So as you know, this is now taking my Ruby application. It's pushing it into Cloud Foundry. Cloud Foundry is then running the detect in the build packs against this to work out which build pack to run. It's, as you can see, detected Ruby. It's then fetching down the gems, staging the entire thing, and then it's going to run it for us. So during this time, I think I should be sacrificing an animal of some kind to the demo gods. It appears to be working. on, come on, come on. We'll get there in the end. So when this is ready, we will have hopefully, a running Ruby Sinatra application. Hooray! So then we can Shift key. Hooray! So Cloud Foundry, isn't it amazing? And I think, whilst that's very, very straightforward, and you may have seen that before, that's a fantastic user journey. I just pushed my app, and I've got something running. What happens when I can't just push my app into Cloud Foundry? What happens next? So traditionally, I take some VMs, I fire up those VMs, I wire them together with storage and networking, and I sort out DNS, and I do load balancing. I do a whole ton of work. I then, obviously, with my VMs, I have to use Chef or Puppet to orchestrate them. And I've worked with clients where they've been having the system, and yes, they're using infrastructure as a service. They're using AWS, but they have a 3-month lag to get things out the door because you've got to write Chef and do various things with infrastructure. So we've still got this long feedback delay, and that's the opposite of what I wanted. I wanted things to be done quick. So this is a problem as I see it. And I think this problem is being addressed by solutions such as Docker. So you see from the quote here, AMI per application will stop being a thing because Docker. So, second demo, quick Docker demo. So I've got a Vagrant VM here with Docker running on it. I'm in a directory with a Dockerfile. If I cat the Dockerfile, you can see I'm using a CentOS base box. I'm installing an RPM. If you want to install that RPM, please help yourself. There's a link there to it. It's being hosted on S3. I'm exposing port 80, and then I'm starting the daemon that the RPM has installed. So this would be challenging at best inside of Cloud Foundry with the build pack model. But with Docker, this is straightforward, simple commands. So if I build this, so build clever server, you saw how fast that was to build this container. And if I run this with that command, docker run, my container is now running. And again, you saw just how fast this was. So if I curl localhost, you'll see again some amazing, fantastic CloudCredo marketing. But you saw just how fast that was to get this up and running. But there's a problem here. What happens when I want to push this out and run this in a distributed system? What happens when I want to deploy that Docker container? This was on a Vagrant VM on my local machine. So what happens when I want to scale this to 1,000 containers? What happens when I want to load balance across multiple containers? When I want to bind in my data services? When I want user administration to say, these users here can look after these containers, and these users here can look after these containers? What happens when I want to deploy to some infrastructure on AWS, and some to my local cloud, and some to Rackspace or HP Cloud? So there's a lot of questions there, and the more astute amongst you will notice that I'm listing the features of Cloud Foundry. So what I'm saying is, I want that CF push journey that I demoed earlier on. I want that journey for Docker. I want CF push for Docker. I want the same speed. So I thought, I love Cloud Foundry, and I love Docker, and I'm going to stick the two together and get the value of both. And thus the idea for Decker was born. So, as you all know, there's a few projects doing interesting things around the Cloud Foundry and Docker space. So you saw Ferdy's talk yesterday, which was great, around using BOSH with Docker. So my approach is slightly different. I've seen this, as you've just seen from what I'm talking about, from the outside in, from the top down. I'm saying I want Docker to be as consumable as possible. I want this CF push journey. So I, as a user, want to just say, there's my container, make it run, make it scale. So, third demo. We're doing well so far. See if this is any faster. Yeah, while this is happening, do you want me to do a squirrel dance? Oh, it was fast. OK. So we've got our space. You can see the application we pushed earlier on, which was CF tests, that's now in that space. In this directory, we have a Dockerfile. If I cat the Dockerfile, you can see it's the same Dockerfile as before. We've just run this in a Vagrant VM. We've got this Dockerfile. But we want to run it in the cloud. So let's give it a go. So I'm giving Cloud Foundry a hint, saying we want to use the Decker stack. Same defaults as before. And now we're uploading the Dockerfile. Cloud Foundry is using the layers, and this Dockerfile has been pushed to this Cloud Foundry before, so it's nice and quick. So you saw how fast that was to start it. Let's curl this. I could type. Hooray! And we've got our amazing CloudCredo marketing. So you've seen how easy that was to just push a container into the cloud. And in case you think it's the same app, we'll now do CF stop Decker test. So that stopped the container. So it really is that easy to push containers into Cloud Foundry. So I think this is how things used to look. Our users could use software. Our apps could go into PaaS, and Cloud Foundry is great in giving us that journey. But VMs, when we had to drop down to VMs, it was slow. And I want things to look like this. I want to bring in a new layer between platform as a service and infrastructure as a service, because I think there is value in containers as a service. I think sometimes we will need to drop down to VMs, but only when we need to have a custom kernel or do something that changes the kernel, because with containers as a service, our contract is with the kernel. So we have these units of currency, apps, containers, VMs, that are being pushed into the cloud, and we're asking the cloud to run them for us. So let's have a look at the roadmap. And look at where Decker's going. So this is fairly obvious. We've just pushed a Dockerfile. I want to be able to push an image of a container. So it will be more bytes, but it'll be more deterministic. So I think this is a good step forward. I want, from Cloud Foundry, non-HTTP routing. And this was actually on, this was actually on James Bayer's list of things today. So again, we can reuse HA proxy. We could do all manner of things here. This isn't going to be too tricky, I think. And then we can also add multiple ports per container. The big challenge, persistent state. What do we do with the containers when they persist some state locally? So at the moment, these containers inside of Cloud Foundry are ephemeral. If you scale up, scale down, if you stop the app and restart the app, the data will be lost. I think this is very challenging. And I think there isn't one answer to this. I think consistency and availability and those kind of challenges in distributed systems mean this is a very difficult thing to deal with. But I think we need to at least have a look at it and make some progress in this direction. This, I think, is awesome. So imagine we were back at the start. So we had our Ruby application just there in a directory. And you want to see some local fast feedback to see how it will run inside of Cloud Foundry. Well, if we type decker build dot, it can use the build pack, the Ruby build pack, and build us a Docker container we can run locally. So you can then just do Docker run for that container, and you have what is essentially a single instance Cloud Foundry running on your local machine with zero overhead. So I was working on this on the plane on the way over here. Unfortunately, I haven't finished it yet. Otherwise, it would have been 4 demos in half an hour, and that would have been a new world record. But this is really close, and I think there's huge value in this for the developer feedback cycle, because you can just rebuild and rebuild and rebuild. You're using the build pack Cloud Foundry is going to use. You're using the Lucid64 root file system. So you've got something that looks exactly the same as the thing that's going to run inside of Cloud Foundry, but it's on your local machine, and you have a much faster feedback cycle. I want remote container orchestration. This currently runs on a custom DEA inside of Cloud Foundry. Why can't that DEA just be a process? Why can't it push containers to Elastic Beanstalk, to Google Compute? Why can't it orchestrate things remotely? So there's no reason why this can't happen. This is where we get quite dreamy. Why just push containers? If you need to work with virtual machines, why can't we push machine images into Cloud Foundry and say, orchestrate this for me? You saw the Diego demo today, where it has the game, and it means things, it can schedule the droplets to run across different execution agents. Why can't they be clouds, and why can't we schedule VMs to run across execution agents? So you could have OpenStack, VMware, AWS, and depending upon price or performance at the time, it could schedule them dynamically for you. So CF push VM image. So I think the future for Cloud Foundry actually looks a little like this. It's not just about apps. Apps are one unit of currency. But if you think of Cloud Foundry as an intelligent scheduler, an orchestrator, why can't we schedule different units of currency? You've just seen containers. We could have VMs as well. And we can back end to things that aren't actually traditionally part of Cloud Foundry. We've got Cloud Foundry DEAs in there for our apps, but Cloud Foundry could schedule onto Heroku. It could schedule containers into Decker, but to Orchard, to Google Compute. It could schedule VMs on your local OpenStack deployment, and then when that runs out of space, you could go out to AWS, the amazing cloud burst dream. We've all been waiting for it for many years. So, I'm not sure this is an ideal. It's just an idea. But I think this is where Cloud Foundry could go. And it's a different paradigm to thinking about Cloud Foundry. So, I started this talk with the quote, "This is a small project from some SI." And CloudCredo are a small company, only 20 of us. We're doing our best. But I don't think this is a small project. I think this is a really big project and a really big vision. And we need the ecosystem of Cloud Foundry to help us deliver on this. So my challenge to you is that I want to collaborate with you. I want to work with you. You've probably heard the CloudCredo name a few times today. Please get in contact with us. We want to work with you to make this happen. So these are my contact details. Please feel free to get in contact. We want to work with you. Any questions? Yeah, thank you.
Stack thing, you said you were pushing the application with --stack. Is that a new thing in the CF client? Or?
So Cloud Foundry is always, sorry, the question was, I was pushing the container with --stack Decker. So stacks have existed for a long time inside of Cloud Foundry, but by default, you only have one stack. You have the looted 64 stack, so that's what's used. So it has existed, it is a concept, but it's not used very frequently because most of the stuff, all the build packs that you know, all use the looted 64 stack. So right now, if we're adding a stack for .NET, I'm not sure how this is going to be reflected when Diego comes online, but you'd have to use a .NET stack. So I'm using a Decker stack, which means I'm dropping out, not using Warden, I'm using Docker instead, and I'm giving the client a hint to say, take this and push it into that stack. Any more questions? Yes?
Why are you using a version of the CLI that's like 9 months old?
Why am I using... It's a very good question. Why am I using the Ruby CLI rather than the Go CLI? Because the code at the moment is against a release that's not compatible with the Go CLI. So there's some routing issues with the code this is working against. So yes, I do very much love the Go CLI. It's brilliant. But this current setup has an issue with the Go CLI. Any more questions? Yep.
So you use the -stack option, which most of us won't have on our Cloud Foundry deployments. Why not go with the Docker build pack instead, so that you can push it with the -b option and acquire Docker during the compile phase of the Docker build pack?
OK, so the question is, why have I used a --stack option rather than using a build pack option? Your client will have the stack option. So all the clients that I'm aware of, the Go client, the Ruby client, definitely have the stack option. You just don't see it used very often. So I think this implementation changed, and any of the pivotal people in the room can correct me on this. I think it maybe was --stack, and then it became -s. I think it may have changed with between version 5 and version 6. But to the best of my knowledge, all the Cloud Foundry clients have the stack option.
I think what he's saying is that without the stack existing in the Cloud Foundry instance, which most of the public ones won't have.
Yeah. So this implementation very much relies upon the stack being there. You have to give it this hint to make this work. Because the implementation is a separate stack. So if you try to do it with a build pack, and it tried to use the looted 64 stack, it would then try and stage and run inside of looted 64, which would then use Warden, and then we'd have some challenges around making Warden work with Docker. Okay.
Yeah, the stack's a higher level concept than the build pack.
Yeah.
Build pack being, oh, I'm going to use this stack already and other stuff.
Thank you. Any questions? Yes? I'm sorry, I couldn't quite hear that. I played the drums for many years, and I've lost my hearing completely.
Yes, so, I have read that Docker helps conserve resources because it uses a slimmer type of image.
Sure.
So if you use this on your local machine, normally if you use Bosch Lite, you need 8 gigabytes of RAM, right? So is this a lot less?
OK, so the question is, if we used Decker rather than Bosch Lite, would we be using far less memory? Is that kind of correct? OK, so that's very, very much my hope. The functionality to run on your local machine is not currently implemented. This was pushing out to AWS. But that Decker build command I showed, where we want to build a container and run it locally, that should mean that it runs in a fraction of the RAM of Bosch Lite. So my laptop here, my amazing Linux laptop, whoever said it's bad, my amazing Linux laptop only has 6 gig of RAM, and I can't run a full Bosch Lite with Cloud Foundry. So I'm being completely selfish here from a user perspective. If this is running inside a container on my local machine, it's going to use a tiny amount of RAM and be a much faster feedback cycle. So I'm sorry, I'm taking up all of Elizabeth's time. I do apologize, Elizabeth. Any more questions? Thank you very much.